Today we are reviewing section 3.5, which covers our linear programming. Let me get this thing to work. Okay, so let's go ahead and start off with the first. I'm going to skip the second one. I think we all did the first part together. So you might need to skip ahead in the video a little bit if you need the back of the worksheet, but I'll probably be going through this pretty quickly. So if you want to review, just stay with me. Okay, so for number one, we're asking which of the following points is a solution to the equation 26 equals 2x plus 5y. So we have these 2-point ordered pairs for A, B, and C, so we're just going to plug those in. So 26 equals 2, for A, it's 0, plus 5 times the y, 5. So 26 equals 5 times 5, which is 25. So that is not true. So this one is not a solution. Do the second one. 26 equals 2 times 7 plus 5 times 0. So that gives us 26 is equal to 14. Also not true. So our last one must be true. Let's go ahead and work through it just to make sure. 2 times x, which is 3, plus 5 times y, which is 4, which does give us 6 plus 20, which is equal to 26. So C is our answer. All right, so let's go ahead and move down to the maximizing and minimizing. So this is what we're going to be doing in order to determine which point maximizes or minimizes our objective function. So remember, this right here is an objective function. That's what I mean by objective function. It's a function, and we want to look for which one, when we plug in the different vertices, is, in this case, the maximum, so the highest answer. So first we have to go to our graph and list what our vertices are. So here I have for my x and my y, actually, you know what? I'm using the same ones for all of these problems, so I'm going to put it underneath. So x and y. Bottom one is 0, 0. We know that's not going to maximize anything unless all of your other answers are negative, in which case they're not. So probably won't have to use that one much. So then I also have, if I have 0, I go up 1, 2, 3, 4, 0, 4. Next one, I'm going to go up one more, so instead of 5, and then to the right, 1, 2, 3. So we end up with ordered pair 3, 5. Now I'm going to go back down. So my x, I go right 1, 2, 3, 4, 5, 6, up 2. And the last one, 1, 2, 3, 4, 5, 6, 7, 0. All right, so I'm going to use those ordered pairs within each of this function. So if I have ordered pair 0, 0, then that means that my function f of x is just 0. So I don't really need that one. Let's see here, I'll make it as a table. So that's 2 times 0 plus 3 times 0 equals 0. So that doesn't work. And then 2 times 0 plus 3 times 4 is 12. 2 times 0 plus 3, nope, not 0 at this point. The next one's 3, 5. 2 times 3 plus 3 times 5 gives me 6 plus 15, which is 21. 2 times 6 plus 3 times 2 is 12 plus 6, which is 18. And the last one, 2 times 7, 3 times 0, gives me 14. So in this case, I'm wanting to maximize. So that means that my answer is this one, whatever gives me the biggest solution. So that means in this case, F. That was ordered pair 3, 5. Was 21. All right, I'm gonna do this one just a little bit different. So this one is 5x plus 2y. So again, 5 times 0 plus 2 times 0, 0. 5 times 0 plus 2 times 4, 8. How many do I have? 1, 2, 3, 4, 5. I'll do the next one here. 5 times 3 plus 2 times 5 gives me 15 plus 10, so 25. 5 times 6 plus 2 times 2, 34. It's probably going to be my biggest one. But just to be sure, 5 times 7, nope, 5 times 7 is bigger. 35. 2 times 0 gives me 35. So that means in this case, G of, what was it, 6, 7, 7, 0. G of 7, 0 equals 35. That's my maximized. And we keep using the same process. So again, 4 times 0 plus 3 times 0, 0. 4 times 0, 3 times 4, 12. 4 times plus 3 times 5, 12 plus 15, so that's 27. 4 times 6 plus 3 times 2, 30. 4 times 7 plus 3 times 0, 28. So that means there's my maximized. That was ordered pair 6, 2. So this is P 6, 2 equals 30. All right, now last one. 80. 80 times 0 plus, oh, this is subtraction, minus 20 times 0 is 0. 80 times 0 minus 20 times 4, negative 80. So this is a situation where you could possibly have 0 as your maximized, but I think we should find something else that works here. 80 times 3 minus 20 times 5 is 240 minus 100. So that gives me 140. 80 times 6 minus 20 times 2 is 480. Oh, this is subtraction, isn't it? Oh, that's just right. Okay, so 480 minus 40 should be 440. And then 80 times 7 minus 0 is definitely going to be our biggest. So that one was 560. So there's our solution for this one. So Q of 7, 0, 560. There's our maximized. All right. In the next part, we are having to minimize each objective function over the illustrated feasible region. So again, new graph here. So new set of vertices. Let's go ahead and document those. So my first one I'm going to use is this one up here. So my x is 0 and my y is 1, 2, 3, 4, 5, 6. Here we have 1, 2, 3, 4. 3 to the right, and 1 up. And for the last one, we have 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh. Oh, come on, don't stop now. 8, 0. There we go. All right. So in this case, we're going to minimize. So we're going to still plug in the values of these different vertices into our function, and we're looking for the smallest number. So in this case, I have 0 plus 3 times 6 gives me 18. second one, I have 1 plus 3 times 4, which gives me 13. The next one, I have 3 plus 3 times 1, 3 gives me 6. And the fourth one is 8 plus 3 times 0, which is 0, so that gives me an 8. So now, because I'm minimizing, that means that this is going to be my solution. So this means that G of 3 ordered pair 3, 1 equals 6 is my minimized solution. And then we just keep doing that. So 5 times 0 plus 3 times 6, 18. Next one is 5 times 1 plus 3 times 4. So it's 12 plus 5, which is 17. 5 times 3 plus 3 times 1. 15, 16, 17, 18. And 5 times 8. If I'm minimizing, then my solution is this guy right here. So I have 17. Order pair 1, 4. H, oops, again. H of 1, 4 equals 17. All right, last few. Again, same process. 3 times 0 plus just y, so 6. 3 times 1 plus 4, 7. 3 times 3 plus 1 gives me 10. 8, 0, the 24. The solution is that first ordered pair. So this is R of ordered pair 0, 6. All right, last one. 15 times 0 plus 8 times 6 is 48. 15 times 1 plus 8 times 4 is 32 plus 15, 32, 42. 3 is 45 plus 8, which is 15 times 8 plus 0 is definitely too much. And 60 minus 40. In this case, my ordered pair is 1, 4. Yeah. S 1, 4 is 47. Okay, so down to the last one. The Sugar and Spice Bakery would like to maximize its profits from cupcakes and deluxe cookies while utilizing its limited supplies of flour and sugar. They have 33 cups of flour and 20 cups of sugar available. Obviously, we cannot use more ingredients than we have available in our kitchen. So that is definitely a constraint. It's a limit. So we'll get to those in the second part here. Each batch of cupcakes requires 2 cups of flour, 1 cup of sugar, while each, that's supposed to be batch of cookies requires 3 cups of flour and 2 cups of sugar. They can sell each batch of cupcakes for $20 and each batch of cookies for $30. So when we're writing the objective function, in this case, the objective function has to do with the profit. So what that means is, and then define the variable used. So I'm going to make x equal cupcakes, y is going to equal cookies, batches of cookies. So my profit is z, or we can do, actually we can do it this way. I'm going to do it as a function. Profit of the number of batches of cupcakes sold and cookies sold equals $20 per cupcake batch sold plus $32 per cookie batch sold. That's my objective function. So that's the one where I'm going to plug in how many I should make to maybe get a certain profit. All right, now we need to look at constraints. So when you think of constraints, you have to think of limits. And the limits are based on inequality. It means that I cannot use more than 33 cups of flour. And I cannot use more than 20 cups of sugar because that's all that I've got. So that's where these come into play. Okay, so the constraints related to the number of batches not being negative, essentially we have to limit ourselves by saying, I can't make negative cookies or I can't make negative cupcakes. Obviously, we could say if you accidentally burnt a batch, you'd have to throw them away. So that would be a negative. But we're going to say if I don't burn any, which we don't want to do, then your constraints not being negative just means the number of cupcakes made is greater than or equal to 0, and the number of batches of cookies made is greater than or equal to 0, right? Because any number greater than or equal to 0 is not negative. Now, the constraints related to the amount of flour available. First off, I know that I have 33 cups of flour available, which means I can't use more than 33 cups of flour because I don't have it. So everything that I use needs to be less than or equal to 33. So that means 33 cups of flour is greater than or equal to. Now we have to go again to our x and y. So I know that x represents cupcakes. So if I go back to my cupcakes, so cupcakes require 2 cups of flour. So that means for every batch of cupcakes I make, I'm going to use 2 cups of flour. And for every batch of cookies, I'm going to use 3 cups of flour. So what I'm saying, that for the 2 cups per batch of cupcakes plus the 2 cups of flour per batch of cookies must be less than or equal to the amount of flour that I have in total, which is 33. Now we do the same thing with the sugar. The constraint related to the amount of sugar available means how much sugar do I have? I have 20 cups of sugar available. So I can't use more than 20 cups of sugar. So 20 must be greater than or equal to. Now, how much sugar am I going to use to make cupcakes? And how much sugar am I going to use to make cookies? So again, we go back to our problem. Each batch of cupcakes requires 1 cup of sugar. So my x just stays x, or if you want, you can put a 1 with it, just so you don't forget that part. And now let's go to cookies. Use 2 cups of sugar per batch. So that's going to be a 2. Again, I'm saying that the amount of sugar I use for each batch of cupcakes plus the amount of sugar I use for each batch of cookies must be less than or equal to 20. All right, that finishes everything for section 3.5. I'm going to make a separate video for section 3.6 so that you've got that available as well. Thanks, guys.